Over the last 16 years, we quantum reporters have gone to extremes to keep you abreast of the changes in science and technology, wherever they are, whatever it takes.
Hi, Quantum Man here, superhero of science.
We've followed the latest theories on the universe and everything.
Called Watson's yo-yo model of the universe. You whirl it around your finger.
Okay, so this orange is actually a laser probe, Bob, and here it comes.
Right, I'm in a gaseous state.
And we've launched you into the heavens to watch the dawning of the space age.
For Venus, the outlook is hot and overcast, but with sulfuric acid showers to continue. Top temperature there, 325 degrees.
We've kept you up to date on the latest technologies transforming our lives. Whatever happened to that ingenious Japanese mousetrap?
Within seconds, a powerful vacuum generator springs to life and sucks the creature through the pipeway at enormous speed until finally it arrives here, dazed, at the bottom of the plastic bag.
Hello, I'm Jeff Birchfield, and welcome to the final episode of Quantum. We've seen amazing changes in technology in the 16 years that we've been on air. Back in 1985, we were very impressed by the personal computer. Now we can hold PC power in our hands. Tonight, we relive the big advances in computer technology and space science. We'll begin with a dramatic one. Ever since July 1994, we could no longer kid ourselves that the solar system was a nice, safe place to live. We saw our close space neighbour, Jupiter, receive a direct hit from the comet Shoemaker-Levy. The wayward space body had been broken into about 20 pieces by Jupiter's strong gravity. One after the other, they ploughed into the giant planet.
We were fortunate to have the Hubble in the right place at the right time to be able to capture this one. That large ring, that big smudge, you could easily fit the Earth inside that diameter. This is one big impact site.
It reminded us the Earth has big impact sites too. It may have been Jupiter this time, but our time will come.
It's not a question of if the Earth is going to get hit by a near-Earth object in the future. It's a question of when. And so you can make the point that the clock is ticking. Either we discover the entire population of Earth-threatening objects, or we get wiped out.
A large asteroid would cause tremendous devastation.
No matter where it hit, continent or ocean, it would dig out a gigantic crater about 200 kilometers across. The dust would block out the sun. The whole Earth would be plunged into complete and utter darkness, and it would get cold. The temperatures would plunge at least 10 degrees centigrade all over the Earth, probably more in most places.
It's very likely that we'll discover an object that is on an Earth-threatening trajectory decades in advance. And so we'll have plenty of time to mount a mitigation campaign. And we have the technology to slow one of these objects down or speed it up just enough so that in 10 or 20 years' time, when it comes near the Earth, it will miss.
1, 0. We have commit and we have liftoff.
While launching an attack on an asteroid remains a scientific dream for now, another dream became reality for astronomers. 5 years after Quantum first went to air, a powerful telescope was launched into the heavens. The Hubble revealed the beauty of the universe in stunning detail.
Aboard the shuttle Discovery, and amidst much fanfare, the Hubble Space Telescope was sent aloft on April 25th of this year. It was billed as the greatest boost to astronomy since the invention of the telescope. But as everyone now knows, there were problems. The first signs of trouble came when Earthbound astronomers trained Hubble's eye to distant stars. To their amazement, they discovered that its principal instrument, a wide-field camera, could only produce fuzzy pictures.
The conclusion we've come to is that there's a significant spherical aberration appears to be present in the optics. A very aggressive set of movements were made, should have significantly improved the image, but it did not.
It was a serious embarrassment for the space agency. But in December last year, a space shuttle crew of 7 spent 11 days and a record-breaking 5 spacewalks to repair the telescope. They added a new piece of optics which corrected the Hubble's fuzzy view of the universe. And on the 13th of January this year, scientists got their first glimpse of what the new Hubble could do.
Hey! Right there!
This is the M100 galaxy as seen from a ground-based telescope. Out in space, the view gets clearer. This is M100 from the original Hubble. And now that the Hubble's optics have been fixed.
While Hubble's images are impressive, there's nothing like going there. NASA's biggest success story of the last couple of decades has been the Voyager mission. A few years before Quantum went to air, the craft gave us these breathtaking views of Saturn. We learnt, rather than a handful of rings, Saturn had thousands, some even beautifully braided. In 1986, Voyager 2 flew past Uranus, confirming it too was a beautiful ringed planet, but with its axis tipped over. Our resident astronomer, David Elyard, gave the commentary.
Ultraviolet sensors found abundant evidence for an aurora like our northern and southern lights, and heat sensors found that the dark side of the planet was warmer than the day side, and that was another surprise.
3 years later, Voyager 2 cruised past the mysterious blue planet.
Last Friday night, the scientific world watched and listened as Voyager 2 encountered Neptune. As expected, we found the unexpected. A blue planet with white cirrus-like clouds and 2 giant cyclonic disturbances, one of which was larger than the entire Earth. Neptune's atmosphere was found to be 85% hydrogen. Its blue color caused by just 2% methane.
Voyager never made it to the outermost planet Pluto, but Quantum did.
Welcome to the planet Pluto, with temperatures around minus 220 degrees and the sun just a faint spark in the black sky. It's not the cheeriest place to be.
Okay, we didn't spend money on sets in those days, so we could spend up on the graphics.
Now, this is a simplified version of how these superdirectional speakers work. Normal audio, like speech or sound that we can hear with our ears.
All right, we blew the graphics budget on wardrobe consultants.
Let's just hope that this invention doesn't fall on deaf ears.
If you could step inside a plant cell...
One of the difficulties for a science program is that you have to explain the science. We must have tried every analogy in the book.
Temperature and cosmic background radiation go together like bacon and eggs.
You square this side and add it to the square of this side. It always equals the square of this side.
The raisins are galaxies. The dough, space.
Charged molecules in a mass spectrometer can be thought of as swimmers racing in a pool.
In the last decade and a half, this is where there have been the biggest changes. Computer technology. Today, the issues may be the thickness of the screen, how much RAM you've got, or just what colours do they come in. But back in 1985, we did some very serious stories about how, in the future, everyone might have to learn how to type, because computers would be everywhere.
Yes, well, by now it will be abundantly clear to you that I don't type all that well. In fact, for people like me, the old hunt and peck is becoming a drawback because, of course, it's painfully slow and these infernal computer terminals are mushrooming.
A few years later, we had moved on from the Hunt and Peck and were blown away by the CD-ROM.
A CD-ROM can hold up to 650 megabytes of information, equivalent to 500 high-density floppy disks. That's haystacks of facts.
And whatever happened to that calculator watch?
Multiplied by 3 equals 36. It's right.
It's terrific, but it's very slow.
For years, the infernal computers had been steadily mushrooming. Then in the mid-90s, the explosion came.
You may have heard of the internet. You may not know what it means or what it does. Doesn't matter. Sufficient for you to know that with modern computers and this new communication method called the internet, Sonia here in southern Australia can connect with classrooms, can send messages, get information from classrooms on the other side of the world.
New York was the first place I wrote to, and I sent it away and it got there in 4 seconds, which blew me away at first.
Big business quickly veered onto the information superhighway, and it turned into a hyperway. Televisions would become computers, and computers would become televisions, and the gurus couldn't contain themselves.
This television thing is a new medium for us. We're going to explore. We're going to try new things. Some of you are going to love the anthem. Some of you are going to wonder about the anthem. The key is that we're persistent. We take a long-term approach. We see what works. We're excited about this, but it's just going to get better and better and better.
And that better future was coming fast. In 1995, predictions were that the newspaper would be dead within 5 years. We'd have the tablet.
Touch the articles that interest you, and they instantly appear. This simulation used the tricks of television. When the newspaper becomes electronic, all sorts of possibilities emerge. The photographs can come alive. It's like having a TV within a newspaper, but you're in control.
No play is gone.
Conventional newspapers are still with us and will be for a few years yet. But in our world of electronic books, Palm Pilots and internet news, it's easy to imagine the tablet's time will come. Computers even intruded into the art world. Melbourne artist and computer scientist John McCormack showed us his electronic etchings back in 1995. His view of artificial life.
Well, it's an interactive museum of unnatural history. Unnatural history. Yeah. There are these imaginary organisms that never really existed, and rather than looking at them as you would in a real museum behind glass screens, they're stored virtually. Some of it's taken from very early biologists at the turn of the century who were first to stumble upon a lot of new species and things that they'd never seen or discovered before. So I found inspiration in that and kind of twisted their words around a little bit to fit into a 21st century idea of what new life could be like if it was discovered.
While McCormack just imagines these machine life forms, some scientists are starting to build them.
You are looking at cogs so minute that they could fit into a watch the size of a flea. These are the first moving parts of the machinery of the future. Micro-machines, where dimensions are measured not in centimetres or even millimetres, but in micrometers, thousandths of a millimetre.
These are another unexpected offshoot of the computer revolution. They're made using the same etching technology as computer chips.
The first micromotor was built here in 1988. Like most of the machines that have followed, it was powered by static electricity. Since then, experimentation has continued, with a wide range of whirling gizmos, vibrating Watsits, and oscillating thingamybobs, all capable of astounding feats, because at this scale, silicon is stronger than steel.
Micro-machinery is now used in many electronic devices, and scientists are working on even smaller gizmos. These are the designs for the tiniest possible flanges, tubes and bearings. They're made up of individual atoms and are being designed at Xerox's Californian research labs. Called nanomachines because their parts are just a billionth of a metre across, these artists' impressions show the science fiction futures that might one day be possible. Tiny submarines cruising the body, zapping out cancer cells, and machines the size of viruses and bacteria that actually reproduce.
Perhaps we could create machines that contain a molecular code for their own replication. Machines that can build other machines. Billions and trillions of machines all working together to build elaborate, intelligent structures and materials.
This fantastic future is still a long way off. Nanomachines exist only on computer screens at the moment, but the day when we can actually build some of these may not be as far away as you think. We can already move single atoms.
Okay, well, I guess this is a moment, a great moment in television history where we actually move a single atom on Quantum. We shall see it for the first time. Once I've picked the atom up, the image is frozen until I put it down again. A moment of suspense. Have I really got an atom at my fingertips? Remarkably, yes.
Don't you want it? While computers have been the great success story of the last couple of decades, with the exception of some cute toys, robots have been generally pretty disappointing. We never did get those personal assistants that would do all the housework.
Industrial robotic arms have worked well, and many production lines now depend on them. And robots are good for brute force jobs, although even there they have their limitations.
And here he's lifting a 200-kilogram barbell. It sounds good, but works out to be less than 1% of his body weight. This is one of the great weaknesses of robots, a very low strength-to-weight ratio.
But getting robots smart enough to think has been far harder than anyone thought.
When we were there, the researchers decided to place a large green drum in the robot's path to demonstrate just how expertly it avoids obstacles. But just when things were looking good, disaster struck. The Terrogator confused the drum for a witch's hat. With its artificial intelligence working overtime, it ploughed resolutely into the mistaken goal.
Trying to get robots to walk like us is something researchers have diverged from recently. There are plenty of other ways to get around.
This is Ariel, built by the iRobot Corporation in Boston. It's equally stable, walking crab-like above or below water.
These robots go pretty fast. We've had them go up to, I think, 5 body lengths per second, or about a half a meter a second. That's fast for a legged robot.
This remarkable robot is capable of transforming itself from, say, a loop to a 4-legged spider. In addition, each of the new modules now carries its own computer, bringing the robot one step closer to thinking for itself.
And there's SnakeBot.
Essentially, something like this can be very flexible in that it can move around a scaffolding structure or any kind of structure. And it can also fixture one end and treat the other end as a hand and essentially be a robotic arm.
Interested in these new robot technologies is, of course, NASA. They've looked at a variety of machines to explore outer space over the years. And the space they hope to one day explore suddenly grew bigger a few years ago.
In July 1991, these headlines swept the world press. A new planet, the first outside our solar system. Embarrassingly, it turned out to be just an astronomical miscalculation, but real discoveries soon followed.
Late last year, the first of the new worlds showed its face to science. What the telescope saw were not planets themselves, but in all but one case, a telltale wobble in the stars they orbit.
We watch the star year after year to see if the star is wobbling in space. Stars shouldn't wobble, they should stay fixed. But if a star wobbles, especially in a circular motion, that means that the star is being pulled by a planet orbiting at a much greater distance.
The wobbles of 7 new planets were discovered in less than a year.
This moment is historic. It's a watershed. Our solar system, and probably we humans living in this solar system, are not unique. We know now for the first time that there are other solar systems which could serve as harbors for life.
With more harbours for life, the probability of us having some extraterrestrial neighbours took a massive leap upwards. When Quantum first went to air, SETI, the search for extraterrestrial intelligence, was considered fringe science. Now, many take it seriously.
We'd reached this fascinating point in our own evolution where the scientific theory says that there is indeed likely to be life everywhere in the universe. And the engineering theory says now we have reached a time where we know how to talk to each other across the distances between the stars.
Yeah. The signal came shortly after 2 a.m.
There's a moderate spike there.
Oh, that does look more interesting.
It was just what astronomer David Blair had been searching for. The signal looked exactly like a message from intelligent life in outer space.
Right.
But before the signal could be verified, it stopped of its own accord. It never came again.
False alarms are not uncommon for SETI scientists, and admittedly the chance of finding a verifiable signal is low. But with 5 professional groups now scouring the skies, astronomers' hopes are higher than ever. Another astronomical hunt for our place in the universe ended with huge success in 1992. The COBE satellite mapped the heat radiation left over from the Big Bang 15 billion years ago. It caused a scientific sensation, like reading the mind of God, as one astronomer put it.
In this unusual map of the sky, the islands of colour are the fluctuations in microwave radiation that COBE measured. They are thought to correspond to the ripples from the early cosmos.
It's an awesome thought, I think, that an imprint from the first, let's say, trillionth of a second after the origin of the universe is actually fossilized in the sky above our heads and sculpted into the structure of the universe in this way.
Of course, science doesn't always get it right.
Last month, science made headlines around the world with an experiment which may mean a new power source is just around the corner. This could be the energy story of the century.
And why not? Many billions of dollars had been spent trying to harness that power that fuels the sun, nuclear fusion.
Now, an experiment in the United States may have achieved it using equipment no more sophisticated than that of a high school science lab. Doctors Martin Fleischmann and Stanley Pons have amazed the world with their discovery.
Stan and I thought this experiment was so stupid that we financed it ourselves.
Stupid because despite the efforts of thousands of scientists over 5 decades, no one has managed to get power from fusion.
But stupid turned out to be the right word after all. Cold fusion left the pages of science as quickly as the anti-gravity force.
Centuries ago, so legend has it, Galileo Galilei stood on a tower not much taller than this one, and he dropped 2 balls of different masses over the edge. Sure enough, they both reached the ground at the same time, and so it's been ever since. But around the world there's growing speculation that Galileo, Newton and everyone after may have got it wrong.
Got it wrong? Because scientists thought they'd found evidence of an anti-gravity force.
It appears to be an extremely weak force which acts differently on different objects.
A Queensland University team measured the strength of gravity at different levels in a mine shaft. Their results clearly showed that something was amiss. Luckily for these guys, it was the measurements that turned out to be amiss.
It really has been an amazing 16 years. Thanks for watching. Good night.
That's great. It starts with an earthquake, birds and snakes, an airplane. Lenny Bruce is not afraid. I have a hurricane. Listen to yourself. Churn world says it's on these dummies.
But this wonderful telescope is all that's between us and Armageddon.
As their name suggests, wimps don't do much of anything except sit around being heavy.
So what, you might say?
Who said you don't need brains to be a television reporter?
The sick feeling comes from having rocks in your head, quite literally.
Why do I always get these stories?
Hello, Alex. Alex, what's this?
What's amazing is how much they ignore you.
It's the end of the world as we know it. It's the end of the world as we know it. It's the end of the world. I feel fine.
Next week, join us for the beginning of a brand new science series, uncovering the sometimes shocking new technologies that are just around the corner. Richard Feidler hosts Aftershock beginning next Thursday night. Stay with us now for The Art Show.